Hi guys, welcome to this newest video on subroutines. Subroutines are immensely powerful. Unless your problem is very simple, then really subroutines are the only way to go. So let's have a look at what I've got here. On the left, if you can see here, here's a block of code. I've abstracted away some of the actual complexity and information here, and so removed it. But the idea is there's some kind of if statement, some commands happen if it's true, else these happen, there's some kind of while loop and these things happen. Now, this is a linear block of code. What we want to do is see if we can break that apart. And over here, you can see I've got the same format, the same if statement is here, the same else, the same while, and the same end while here. But what you see differently is there are a bunch of blue bits and pieces. These blue bits and pieces are not there for any reason whatsoever. The idea is I've taken this bit of code and I've packaged it away in its own little box here. Well, how do you link this to here? Well, that's a good question. And effectively what you do is this makes a call to run this code. Once that code has finished, it jumps back here. Once this code is being called, it calls this code, jumps over here, runs through here, jumps back again. That's the idea of subroutines. Effectively, subroutines are a way of you breaking apart what was a big problem into smaller pieces that you can write individually. Sound familiar? It should do, because that's what decomposition was all about. You take a big idea, you break it into smaller parts, and subroutines and writing modular code helps you succeed in doing decomposition. And today that's what we're going to learn all about. And in fact, why don't we take a moment to think through what the advantages are? Well, it works well with decomposition. You break the idea down, and now each of those smaller pieces, maybe they can become individual subroutines. Since you've broken them into a subroutine, they can individually be tested for valid, invalid, and borderline data. You can do some black box testing to see where is the problem. Is it inside this subroutine? Instead of a big chunk of code where it becomes difficult to find, now you have subroutines and you can isolate problems and fix them there. You can have members of a different team work on different subroutines, and you can actually work as a whole group, and this massively speeds up development. It reduces repetition of code. So before, if you wanted to run the same bit of code multiple times, well, option one could be that you use some kind of iteration, like a while loop or a for loop. But often what you might have to do is literally copy and paste that code. You don't have to do that anymore. You break away that code into this box, into this subroutine, and every time you want it, you call it. We'll see the details of that in a moment. Finally, it makes code easier to maintain. In the future, if you want to just develop your code, instead of having to worry about this giant chunk of interrelated code, you can just focus on the block, the actual block itself, a subroutine, and develop that individually. So here's an example of a little bit of code we've written here. It doesn't do anything sophisticated. It just says, welcome to box size calculator. Please enter the height, width, and depth of the box. And we're storing that as 3 variables here. And then it just outputs what the height, width, and depth is. The plus concatenates it to the string and gives us that information. And what we're going to do is we're going to see if we can break that apart a bit and turn that into our subroutine. So here is a first go at trying to break apart that subroutine. So if we're looking at it here, what we have is this top section, same as it was before, but now we have this bit here, box size. And in this other box, I've got a subroutine. And the way you declare a subroutine is you just use the key word subroutine. Box size is the name of the subroutine, so that's how I call it. So when I call that, it jumps over here, and then it says to output, the box is height times width times depth. Now here's a really crucial thing for us to understand. The height and the width and the depth, they don't exist inside this box. In fact, they'll get that from here. So height is referenced from here. Width is referenced from here. Depth is referenced from here. Because this main bit of code here, that any variable declared there is called a global variable. A global variable like height and width and depth can be viewed anywhere throughout the code. So any subroutine can view that variable. So global variables can be viewed throughout the scope of the program in any subroutine. The opposite of that is something called a local variable. Over here, I've tried to take it to the next step. So here, I've got a very similar format, output, height, and width, and depth. These things are taken here, but this time, do you see the subroutine looks different? Inside these brackets, I've actually got a few things written down. I've got H, W, and D separated by commas. These are called parameter values. That means that this is receiving a H, W, and D, and with that, it multiplies them and returns it. Do you see here in this box size position, box size brackets, it's blank? Well, actually, that's where I can send these values. So I'm going to have a go at trying to write in our values. So the first one was H, and that's going to be height. And I have to use the same format, so I'll put a comma, and then it's width. And finally, it's depth. Now let's see if we can understand what's happening here. So even though I've called this height, width, and depth, when the height is sent to the box size here, it's received as a H. So height is being passed as a parameter to H, width has been passed as a parameter as W, and depth is passed as a parameter of D. Now, H, W, and D only exist inside this subroutine. So these variables are called local variables. This H, W, and D can't be viewed in here in the main bit of code or any other subroutine. They exist and are only visible in this subroutine. Height, width, and depth are sent as parameters. They are multiplied out, and then when the subroutine is ended, poof, they disappear out of existence. So they're only existing while the subroutine is being executed. So that's local variables. Finally, we have another twist to how subroutines are worked. And you can see, I don't know if you can see the additional keyword here. Do you see? We've done the outbox, box size, height, width, and depth. So we're passing these values as parameter values. However, in here, do you see it says return inside the subroutine? Return means that the message is actually sent back. So it's not going to output this string anymore. It's actually going to return the string here. And then it's outputted. This is tricky. So let's talk this through. So at this point here, all those values are sent and are received into this subroutine. When the subroutine receives it, it does this calculation here, generates this string, and then that is finally returned here and then outputted. So sometimes you send values to a subroutine and it does something, but it never returns it. Sometimes you can send it and it can be returned. Right, let's have a look at a subroutine in action. Here's an exam question. It's using a trace table. Trace tables, if you remember, are when we look at the values of variables and record their changes as they go along. The subroutine is called with total 3, 4. And if we look here, total out as A, B. So 3 is connected to A, 4 is connected to B. And then the first line is A plus B are being assigned to C. So updating C with this, and then there's while A and C. Well, do you know what? Let's just start doing it. Do me a favor, since this is a we bit, as in we do this together, I'm going to start working through it. But if you can pause as you're going along and you figure out what you think would be the next stage, that would be great. So A, as we say, the first A is going to be 3 because that 3 there is going to be that A down there. And then since the 4 will be that B, then B will become 4. C over here, do you see, is A plus B. So C, in fact, will be 7. Then it says, while A is less than C, is 3 less than C? Yes, it is. What happens next? A is A plus 1. Well, if A is 3, then plus 1 is 4. And then we can say A has become 4. B is B minus A. Well, B was 4. A is now 4. So B becomes 0. What about C? Well, C hasn't changed. So we'll come back to the beginning of the while loop. And it's saying, well, A is less than C. A is 4. C is 7. So it's still less than. A is A plus 1. So that becomes 5. B is B minus A. Well, A is now 5, so 0 minus 5 is minus 5. C hasn't changed, while A is less than C. A is 5, C is 7, so it's still true. So it's A plus 1, so that's 6. B is B minus A, so it was minus 5, but then we're minusing 6 from that, so that's minus 11. C stands as 7 still. Is A less than C? Well, 6 is less than C, so it continues. A is A plus 1, so that's 7. And then B is B minus A, so that would be minus 18. Come back to the beginning, and now if you can see, well, A is less than C. Well, A is 7, C is 7. 7 is not less than 7, so the while loop ends. And then we return B, so we'd return minus 18. Okay, let's have a look at this. It's another exam question, but this is a bit of a change. Not a trace table anymore. It shows you an algorithm of a subroutine. And the first question is, describe the algorithm in terms of its inputs and of its outputs. Well, straight away, this subroutine you see has got the name of the subroutine is sub R, so that's the identifier of the subroutine. And then it has 2 parameter values, XS and YS. So the first thing we can answer is that in terms of inputs, algorithm, apologies for my handwriting, has 2 parameter inputs, XS and YS. Now, what else can we glean from how this works? Well, you can see that there's a variable called result that's initialized to 0. There's a for loop that starts at I, position 1, to len. Now, len means the length of it. Now, there are 2 things this could be if it's the length of. It's either A, an array, and it's getting the length of the array, or B, it's a string. So that's interesting. Now, there's actually a bit of a boo-boo here, because the index of a string or the index of array should start at 0. I think in the old spec, it used to start at 1 for these things, so I expect that this should start at 0 and should not go to the length, be length minus 1. So a little thing to watch out for. But what that means is it's going to, in a for loop, step through each part of it, and every time it's stepped through, 1 will be added to the result. So what that means is that it's going to return the length of the array. And then we're going to do the same here, and it's going to give you the same thing, the length of YS, but it's going to keep on adding to it. So it's going to give you the total length in the return of both of these arrays. Anyway, this is about inputs and outputs. So let's talk about what else we know about the input. XS and YS must be either an array or a string. So they're either a string or an array. In fact, it must be a one-dimensional array if you think about it. And what output? Well, there's only one output, and the one output from this is the return statement. So we can say that it returns the variable result. Okay, let's look at the next part of the question. The question is, what is the purpose of the algorithm? Aha, we just discussed this. So the first for loop returns the length of XS. The second for loop, the first for loop looks at the length of XS and counts every single character or every single part of the array. And then YS does the same. and it adds those things in total. So it gives you the length of both items added together. So it returns the combined length of both XS and YS. And for the final bit, result is a local variable. We talked about this earlier within the algorithm. What is a local variable? So we can see result is there. Why is it local? It's local because it's declared inside this subroutine. It's declared inside here. So that means that the local variable is only visible inside this subroutine. If there were another subroutine here, or there was a main bit code up here, it would not be visible. So what we're saying is result is only visible, a local variable is only visible within its own subroutine. And as soon as the subroutine stops, as soon as the subroutine is finished executing, it disappears again. And it's only visible there, not visible outside it. Okay then, we're really stepping it up a bit now. We're going to have one of these longer 7-mark programming type questions. These are the ones that are incredibly anxiety inducing, but we'll just stay calm. We'll read through it together and we'll give it a try. Remember, this is a we again, so I'd really appreciate if you gave it a shot before you watched the way I solved it. So let's read through. A developer is using the structured approach. I refer to it as modular, i.e. they're using subroutines to develop a solution and wants to write a subroutine to solve one of the sub-problems. So this person's decomposed an idea and broken into a bunch of sub-problems that he wants to use a subroutine individually to solve. This subroutine should have the following interface. The interface is basically the top level. So it's the thing that says subroutine, the keyword subroutine, and then the name of the subroutine, and then whatever parameter values it may have. The subroutine is called find minimum. Okay. The subroutine takes an array of integers as a parameter. Okay. It doesn't actually say the name of it right now, but that's fine. We can do that. And the subroutine returns the smallest value in the parameter array. Okay. Interesting. So using pseudocode or a flowchart, well, we're going to try and solve this, I think, with some pseudocode so as we remember how it's written. So I'm going to bring this up here. So first thing you want to remember is what's the keyword for writing a subroutine? So that is literally the word subroutine. Bit of a trick question right there. So subroutine, and then we have to remember the name of the subroutine they wanted to use. I believe they wanted us to call it find minimum. So find minimum. Excellent. And then we open brackets for parameter values. Does it have any parameter values? Well, it said it was going to take an array. Now, since it didn't actually say the name of the array, I believe what it said was it was going to be a bunch of integers. So that'd be whole numbers. So let's just, for argument's sake, we'll call it nums. So a set of numbers. Now, what we want to do is find the minimum number. So the first thing I'm going to do is I'm going to initialize a new variable called min, and I'm going to assign it the value of the first position in nums. So in this array. Remember, hopefully you remember that with these arrays, you do square brackets, and then 0 is the first position in the array. Now, I want to step through the array until I've got to the end of the array. And every time I find a value, I want to compare the value at that position in the array. And if it's smaller, I want to update min. Now, the only problem we're going to have here, we've made one big assumption. And the one big assumption is that the numbers array is not empty. If it was empty, we've already made the thing crash because we said, look in the first position and update minimum with it. Well, if nums is empty, we've referenced something with nothing there. The program's fallen over. So we've made a bit of an assumption. Anyway, we know how to do a for loop. So for, and we're going to go from, let's use I for index. We don't need to start at 0 because we've already done 0. We'll start at position 1 and we'll go up to, if you remember, they were showing that earlier, the length of nums. Now let's say there were 6 numbers. That would say we're going to go from position 1 to position 6. But because we started at position 0, it's going to be 0, 1, 2, 3, 4, 5. So if we go up to 6, we're also going to make the program crash and cause a logic error. So we actually have to say not just nums, but nums minus 1. So it would go up to, if there were 6 numbers, it would go up to position 5. Now, as we go through this array, we want to say if, well, if what? If the value of, if nums at position I, so the first time around, that'll be position, that will be position 1. If that is smaller, than min, i.e. it's a smaller number than the first one, well, we need to update min. So we say min is now being updated to nums at position, square brackets, at position I. And then we'll have it update, we'll end the if. If it's larger, well, then we won't do anything. So we'd make it go. Now, if you see what's going to happen is then it'll become I will be 2. And is the value at index 2 smaller than min? If so, update min with that value. If not, end. And I'll keep going until it's finished. And then we need to end the for. If that for loop is ended, we then are supposed to return what the minimum number was. So we should say return. We have to return what the minimum number was. And where is that held? Well, the minimum number is held in this variable here called min. Is there anything else to do? Well, yes, there's one extra thing we need to do. We need to end the subroutine. And then hopefully, et voila, we have finished that example. Okay, people, now it's over to you. Be calm, think it through, don't race it. The first question is essentially saying, why do we use local variables? Why is it good practice? The second question is asking you to solve this problem using a subroutine. Third problem is, why do we use the benefits of a subroutine? Now, I told you these specifically. I haven't given you the actual reasons in this video for why we use local variables. The main reason why you want to use local variables is that it helps contain where that variable can be accessed from. So you can't accidentally change its value somewhere else. So local variables, since they can only be changed or accessed within that subroutine, it stops the programmer, it stops you accidentally changing it some other point of the program. So it helps you reduce the risk of you making errors effectively. Okay, give these reasons a try.